Hello, Mario! 2019 Engineering Maths Weekly Quiz 8 Review. Hello, hello! Welcome, welcome, welcome. Hi, 3.5. Wow, Quiz 8. Only 2 more to go. Maybe. Quiz 8. A review. So, remember, 1 free spin of the Wintech vending machines to the first student of Wintech, of maths, engineering maths, who is able to identify the scene in the background by placing a comment below the video. Yep. 1 free spin of the vending machines. Now, if you're trying to look up this venue, it's called exactly what it looks like. It looks like, well, that's what it is. Find out where it is, and, well, you could be a winner. Alrighty, so let's get on with the show and over to the big screen. And here it is. Big screen's all nicely set up there. And, well, we're going to get the tablet out and get that organised. The Wacom tablet here, as you can see, that's what I use. And the special pencil. And, well, we'll just put one little click up here where we want to start. I find that works. And then away we go. So, here we go. dy, differentiate. dy by dx. For this one, equals 4 times 5 is 20. X, 4 minus 1, x cubed. Okay, that's done. Plus 7x, that differentiates to 7. The x just goes away. Minus 2 times 5 is 10. And x, and drop it down 1, x to the power of 4. That's it. Done and dusted. 2 marks. Give that man 2 marks. Easy as. Okay, that is the answer. As I just check on my notes here. Yep, 20x cubed minus, well, you could rearrange it, but minus 10x to the 4th plus 7. So you just work through each unit as you go. Right, question 2. Let's have a look at this. Well, it looks like this is 2 functions multiplied together. We could say it's x to the power of 4 multiplied by e to the power of x. Yep, I think that's correct. So what we've got to use here is what we call the product rule. Product. Product means 2 numbers multiplied together. The product of 4 and 5 is 20. It's just they're multiplied together. So we're going to use the product rule. Okay, and what that says is that dy by dx and what we do is we give each of these functions a name. So we call this one a function of x. We call this one f of x. And then this one here, g of x. Because they're separate functions. The exponential function and the, well, a power function. So dy by dx equals f of x, f dashed of x, which is the differentiation of x, f dashed of x times g of x. So that's just the differentiation of the first function times the second plus g dash of x, differentiation of the second function times the first. Now I can remember doing this at school in the 1960s, and so it was the diff of the first times the second plus the diff of the second times the first. Alright, so what have we got here? So let's say we've got f of x, to be absolutely clear, f of x equals x to the power of 4. Okay, and so differentiation of x, f dashed x, equals 3, oh no, sorry, I slipped up there. Oops, too far. Equals 4x cubed. Okay, so we put the 4 in the front and drop 1, 4x cubed. Now let's take g of x, and that equals e to the x, and g dash of x, which we look up on our formula sheet, it's on our formula sheet, g dash of x, we look that up on the formula sheet, and that's just equal to e of x. Unchanged. Just doesn't change. The differential is the same as the value. All right. So the answer that we want, dy by dx, equals, all right, f dashed x, 4x cubed. Times g of x, e of x, plus g dash x, e of x, times f of x, which is x to the 4th. Now you could just leave it like that. Well, you can just leave it like that if you wanted to. You can simplify it if you want to. You could put x cubed, and some people did this. Just remember that if you do decide to simplify it, x cubed e to the x brackets 4 plus x. Okay, so either one of those is acceptable. 2 marks to you, my good man, for getting that one right. And that's the product rule, because the two functions are multiplied together. All right. Yeah. Alrighty. 4 plus x. So we've got 1x left over there. All done. Oh, well, there you go. That was pretty painless. 4 marks we've almost passed. Now, this one here, differentiate this one here. Now, this has got one over the other, one function over the other, and it's like a fraction. So the thing that we use for those is called the quotient rule. The quotient rule, because it's a quotient. The quotient rule. And, well, these are on your formula sheet, so you don't have to remember these. They're on your formula sheet. You just have to remember which one they are. And it says dy by dx okay, I'll put that. It's for the case where you have y equals u, some function u, over some sort of function v. So dy by dx equals u dash, so that's the differential of the top, okay, times v, the differential of the top times the bottom, minus the differentiation of the bottom, v dash, okay, v dash, times the top, all over v squared. Okay, all over v squared. Right, so what have we got here? We've got u equals 2x plus 7. Okay, and u dash, well, differentiation of that is 2. Just 2. And then we've got v equals sine x and v dash equals cosine of x. So there's all the little parts of our equation, and now we've just got to put them together. Dy by dx. Now just remember, dy by dx is the same as f dash x or x dash. They all mean the same thing. They're just different ways of saying the same thing. All right, so let's follow the recipe, or the formula as we call it in maths. So u dash is 2. And v is sine x, 2 sine x. Minus v dash, which is cos x, times u, which is 2x plus 7. And then that would all be over v squared, which of course is just sine squared x, or sine of x. We tend to write it in maths, sine squared x, but it is the same as sine of x all squared, like that. You could possibly leave it like that, or you might want to expand the top out a little bit, and you'd have 2 sine x minus 2x cos x minus 7 cos x all over sine squared x. So if you wanted to expand it out a bit. And there's not much more you could do with that. Oh, that would be, have a bracket. Okay, so it's cos x times 2x. So it's negative cos x times 2x, negative cos x times 7. So that's where that all comes from. And once again, 2 marks for that. 6 marks. That's good. That takes you into the 60-40 rule material. Okay, so that's questions 1, 2, and 3 done. We'll turn off layer 1. And that, what happened there? We'll go to layer 2. Oh, there's layer 2 there. Okay. No, it's not. All right. Turned off layer 2. Oh, that's layer 2. What's background layer? Oh, we've got a bit of a problem here. Layer 2. What happened there? Okay, so we'll have to add another layer here. Add a new layer. Okay, which will be layer 3. I'll turn off the background. And we'll import a layer image. And it'll be layer 2. Okay. Oh, crisis averted. A little bit of a problem there on the side. There's a little bit of background. Oh, I don't know. It's going a bit funny, but well, we'll try and get this done in one take. So, find the equation of the tangent line to y equals 7x to the 5th plus that, where x equals 3. So, the story here is that dy by dx, we need to get the felt pen going here. Layer 3, what's going on here? Turn on layer 2, see if we can come back to layer 3. Layer 2, turn layer 3. It just wants to point. Oh, there we go. Now we've got our felt pen. The current layer is invisible. Cannot be edited. Put it out, can. Okay. Alrighty. So we're back underway. So the thing is about this is that the dy by dx is actually the slope of the graph. Oh dear, what's going on now? So we need to just get it started with the mouse as I swap from the... Okay, so that should drop me back there. Right. Okay, all right, so the slope of the graph is dy by dx gives us the slope of the graph. So if we can, here we go, yeah. So dy by dx equals 7 times 5 is 35 x to the power of 4. So that's the slope of the graph at any point on the graph, plus 2 2s of 4 x, 4x, right? 35 x to the power of 4 plus 4x. So we want the tangent line at the point where x equals 3. So where x equals 3, dy by dx equals that. And well, perhaps I'll better write that again. When, so that's what we're dealing at here. When x equals 3, dy by dx equals 35 bracket 3 to the power of 4 plus 4 times 3. Okay, so let's get our calculator out now and have a look at that. So let's put that on the calculator. So we've got 35 times x, 35 times 3 to the power of 4. Moving on, plus 4 times 3 equals 2847. 2847. Okay. Equals 2847. Now that's the slope of the graph. Now when x equals 3, we also need to know what y is. And y equals, when x equals 3, y is going to equal 7, 3 to the 5th. So we just put that in there, 3 to the 5th. 3 to the power of 5 plus 2 times 3 to the power of 2. And that equals, so we can do that on our calculator. Right, all clear. 7 times 3 to the power of 5 plus 2 times 3 squared equals 1719 equals 1. Okay, so when we come back from here, we get that with the, so that's with the mouse, and then we can use the tablet. 1719. Now what we know about straight lines is that y equals m x plus c. And what we know, of course, is that this m is the slope of the graph. And we know what y is, and we know what x is. So now we can fill in here. We can say what y is 1719, because we want to find the equation, and so we need to know what c is. 1719 is y. M is 2847. X is 3, remember, because it's when x is 3, plus c. And so we want to get c on its own, so we can see there that we've got to subtract minus 2847 by 3. If we take that away from both sides, we're going to get c equals 1719 minus 2847 times 3. Okay. All right. So let's get that up on the calculator then. So what we've got there is, I think I'll do that with my mouse here. It's a bit easier. Let's see, 1719 minus 2847 times 3 equals negative 6822. So to just put us back and put the pen back in here. Okay. Negative 6822. And so the equation of the graph is y equals 2847. This is the equation of the tangent to the graph at the point where x equals 3. 2847x minus 6822. And that's your equation of your graph. And if you wanted to just check that out, you could. All clear. 2847 times 3 minus 6822 equals 1719, which is what we got. So there's another 2 marks there. Pretty reasonably easily gained there. Nothing. Another 2 marks for that. There's actually 2 marks for each question. So now the next one we have to, oh, what's going on here? Oh, Control Z. Oops. So, looks like we've got a bit of a problem here of some sort. Seems our canvas is not big enough, or it needs to be. I see what the problem was. So we need to. Okay. Oh no, that's all. Oh, worked out all right. Okay, so I sorted it, I guess. There we go. Oh, no, we didn't. Why won't that stay up there? Okay, let's go back to our hand here and our image won't fit on the graph. That's annoying. Oh, I thought I had this all sorted out. Damn. Well, we'll just go with it here for now. And I'll try this option here. Options, edit, file, resize image together with canvas. Okay, no. Damn. Layer 1, layer 2. It's not moving the image. I want to move the layer image. Okay, I'm going to add another layer and see if I can get that bit there. Add new layer, which will be layer 4. Okay, let's just options, zoom right down. Okay, and import layer image, which will be layer 2. That's it there. Okay, so this is layer 4. All right. And now we will cool, and then we'll go to this pen here and to this pen here. Right, and we'll go zoom plus. That'll give us back into there. Control Z. Okay, layer 4. Okay. All right, so now we can do this one here. Alrighty. So let's get this all sorted out. So we've got to be a little bit careful here with this particular one, and because we need a lot of room. So we'll just see how we go, and we'll just start there. So for P, that's where it's intersecting the y-axis. So we go when. That's when, and we're trying to find P here. Should put that up there, P. So that's when x equals 0. So when x equals 0, y equals minus 0.5 cosine I've put a bracket there. Probably don't need that. I'll just take that out. Okay, minus 0.5 cosine bracket 3 times 0 minus 2. And remember that this is in radians. So that equals 0.5 cosine negative 2. So let's put our, just to be checked here, all clear, shift mode, 4 is radians, and then we go 0.5 times cosine negative 2, close the bracket, equals 0.0208. 0.0208. Oh, that's not what I got before. I just might check that. 0.5. Oh, because it's minus 0.5. Oh, I didn't. I've just checked it with my notes. So we'll just go there and put the minus in. Equals. Yes, and it's not. It's 0. Minus 0.5. Oh, no, I've put 0.05. Oh, I can see the problem there. Yes. Okay. Yeah. Now. Yes. 0.2081. Finally. See how careful you've got to be. 0.2081, rounding it to 4. Now my error was I put 0.05 in there, and then I didn't have a negative in there, which swapped it around. So you must be very careful in that, putting that in, and that's, well, classic example. So I've provided you down here with a means of there, so we can write it in here, 0, and that'll be 0.208. All right, and that's worth 2/3 of a mark. Okay, so that's worth 2/3. So if you just got that done, you'd probably get it rounded up to 1 mark. Perhaps it should have been a half. But anyway, 1 mark. So that's what I did. P, now next we've got Q. So we're going to do Q. And that there, of course, is when y equals 0. So when y equals 0. So I'll just underline those because they're So this is when y equals 0. So we could put a 0 here. Now you might get some marks for that. Okay, so when y equals 0, okay, so that means that we've got 0 equals negative 0.5 cosine 3x minus 2. Okay, so we can divide both sides by negative 0.5. Oh, both sides. Negative 0.5. Okay. And that's going to give us 0 equals cos 3x minus 2. All right. And so then we can say, to undo that, we just go cos to the negative 1 of 0 equals 3x minus 2. Okay, and then we're off to our calculator here. All clear. Cosine. Oh, all clear. Shift cos to the negative 1, 0 equals a half pi, or pi by 2. So we can say that's oh, let's drop down here a minute. That's equal to equals pi by 2, which is just a number. So we can add 2 to both sides, and so we get 3x equals 2 plus pi by 2. All right, and then we can divide through by 3, and we can do that. X equals and here's what we can do. Let's all clear. So x equals 2. All clear. We need one of these, and then we've got 2 plus one of these again, pi by 2. Oops. By 2, all divided by 3. Equals 1.1903. 1.1903. But hang on a minute. 1.1903 is there on the graph. I think. That's 1.1903. That's not what we want. What we've got here is this here is half a period. Half of the period. Now from our formula sheets, period equals 2 pi over b. Which in this case here is 2 pi over 3. Okay, and that's from there to there, and we need to take half the period from here. So the x value at q will equal 1.1903 minus 2 pi over 3, half of that. So we'll put that over 2 again. So let's work that out. Okay, so we get, oh, we've already got that there. 1.1903 is already there. So then we just go minus that there, which is 2 times pi over 3, and we need to bring that back here and do that. No, that's not going to work. What I'll do there is, oh no, I'll get it right. I'll I could just divide by 2, but I won't. I need to get this right. Oh, so delete. Okay, so we need to go there and then there again, and then that's shift 2 times, oh, delete, so that's 2 times pi over 3 over 2, okay, equals 0.1431. Okay, 0.1431, and checking on the graph you can see that that's a much better result. Fortunately we were given an accurate graph there. 0.1431. Now, if we look at this one here, now we're going to find R, and right, so we know at R that that's, well, we can see there that's going to be the amplitude. We know that the amplitude is 0.5. well, it's negative there for that one, but it's actually 0.5. And we can see that there, 0.5. So what we can see here is when the coordinate of r is going to be down here, when y equals 0.5. So now what we get is 0.5 equals negative 0.5, that still says that, sine, I don't know, I keep putting that bracket around there, I'll leave it there this time, sine 3x, and that's what we want to find, 3x minus 2. It's pretty much the same calculation, except this time we divide through by negative 0.5, so that's negative 0.5, and that's negative 0.5. That would be over everything because they're multiplied together. And then what we get then is, of course, we get negative 1 equals sine 3x minus 2. Okay. Oh, no we don't. It's cosine. Another silly mistake. Cosine. 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 That should be cosine. Very easy. We've got to be very careful. Cosine. That's better. So then we can say cos to the negative 1 of negative 1 equals 3x minus 2, and then we can head over here. Oh no, all clear. Cosine to the negative 1, negative 1, I'm not repeating myself, that's right, equals pi. Is it? Pi, yes. Okay, equals, so now we get pi. Is that, yes, that's right, equals, just checking my notes. I'm actually making mistakes even though I've got my notes here with it all written out. 3x minus 2. Alright, so we add 2, pi plus 2, and well, that equals 3x. Divide through by 3, just exactly as we did above. So we get x equals pi plus 2 over 3, and that equals, oh, remember that the y value here is 0.5. Okay, that's how that is, and then we've got to go to here, and so there. All right, shift pi plus 2, drop it down, 3, that's it, done, equals 1.7139. 1.7139. 1.7139. 1.7139. Okay. Oops. Put that in here. All right. 1.7139, and you get 2/3 for that answer and 2/3 for that answer. Okay. Yes. Alrighty. So, yes, a little bit of shenanigans there with my use of the smooth draw free. I will go through and try and fix all that up so that I can produce a set of notes for this. And yeah, but well, we got through it all, so that's all very good there. Hopefully that's helped you. What I would recommend is, so if you didn't do quite so well with the exam, you need to go through and review, or the quiz, review the questions and make sure you can do them. Then get a blank copy of the quiz and do it again in exam situations. Get it, and you keep doing it until you can do it. Because if you can't do this, you won't be able to do similar questions in the exam. It's just so simple. And, well, you know, if you've still got trouble, there's the comments below the video. You know where to find me. You can email. There's many ways you can contact. maurieio@maurieio.com. You can look me up on the YouTube, on the internet, everywhere. So, that's it. Quiz 8. All done in one take. Don't forget, if you can put the name of this scene, if you're the first person to put the name of this scene in the comments below the video, 1 free spin on the vending machines at the Wintec Rotocarry campus. Oh, man. That's what a prize. So, all good. Cheers. And, well, we'll see you again for quiz 9. Bye.